Overheating breakers in Siemens 125-ounce panels with aluminum busbars is a recurring issue that stems from the oxidation of the aluminum bus. Over time, the aluminum oxidizes and forms a layer of aluminum oxide on the surface. This oxide layer is non-conductive and creates a high resistance path for current flow. When current flows through the oxidized busbars, it encounters increased resistance due to the oxide layer. This resistance causes the busbars to heat up, leading to overheating of the breakers connected to them. The increased temperature can damage the contacts of the breakers, causing them to burn or fail. The process of oxidation also produces dusty oxide deposits on the busbars. These deposits further increase the resistance and contribute to the heat buildup. Brushing with a wire brush removes these deposits, but it does not address the underlying issue of oxidation. Replacing the panel with a new one that has copper busbars is the recommended solution. Copper is more resistant to oxidation and provides a more reliable and efficient current path. By replacing the panel with copper busbars, the issue of overheating breakers caused by aluminum bus oxidation can be permanently resolved. In addition to replacing the panel, it is also important firstly inspect the electrical system for any other potential hazards or areas of concern. Secondly, ensure proper ventilation around the panel to prevent heat buildup. And thirdly, schedule regular maintenance and inspections to monitor the condition of the panel and electrical system. To elaborate on the oxidation of aluminum busbars, it's essential to understand the electrochemical process at play. Aluminum, when exposed to air, readily reacts with oxygen to form aluminum oxide. This isn't necessarily a bad thing initially. In fact, the aluminum oxide layer is what protects the underlying aluminum from further corrosion in many applications. However, in the context of electrical connections, this oxide layer presents a significant problem. Unlike copper oxide, which is somewhat conductive, aluminum oxide is a very poor conductor of electricity. This means that even a thin layer of aluminum oxide can introduce substantial resistance into an electrical joint. The resistance is not uniform across the surface of the busbar. It varies depending on the thickness and composition of the oxide layer. This non-uniformity leads to localized hotspots where the current is forced to squeeze through areas of lower resistance. These hotspots generate significant heat due to the power dissipated as current flows through the resistance according to Joule's law, which states that the power dissipated is equal to the current squared times the resistance, or P equals I squared R. As the temperature increases, the rate of oxidation also increases, creating a positive feedback loop. The higher temperature causes the aluminum to oxidize more rapidly, which further increases the resistance and generates even more heat. This thermal runaway can lead to the eventual failure of the connection. The dusty oxide deposits that are observed on the busbars are a byproduct of this oxidation process. These deposits consist of finely divided aluminum oxide particles that have flaked off the surface of the busbar. While brushing with a wire brush can temporarily remove these deposits and reduce the surface resistance, it does not address the root cause of the problem, which is the ongoing oxidation of the aluminum. Furthermore, the act of brushing the busbar can actually exacerbate the problem in the long run. The abrasive action of the wire brush can scratch the surface of the aluminum, creating new sites for oxidation to occur. It can also embed small particles of the wire brush material into the aluminum, which can act as catalysts for further oxidation. Therefore, while cleaning the busbars may provide a temporary improvement, it is not a sustainable solution. Replacing the aluminum busbars with copper busbars is a more permanent and reliable solution because copper is significantly more resistant to oxidation than aluminum. Copper forms a layer of copper oxide on its surface, but this layer is much more conductive than aluminum oxide. In addition, copper oxide is more stable and less prone to flaking off the surface of the metal. This means that copper busbars maintain a lower and more consistent resistance over time, which reduces the risk of overheating. When selecting a replacement panel with copper busbars, it's important to ensure that the panel is properly rated for the intended application. The panel should have a sufficient ampacity to handle the maximum expected load, and it should be installed in accordance with all applicable electrical codes. It's also important to ensure that the copper busbars are properly sized and connected to the breakers. The connection should be tight and free of corrosion to minimize resistance. In addition to replacing the panel, it's also important to address any other potential issues in the electrical system. This may include inspecting the wiring for signs of damage or deterioration, checking the breakers for proper operation, and ensuring that the system is properly grounded. Proper ventilation around the panel is also crucial to prevent heat buildup. The panel should be located in a well-ventilated area, and it should not be obstructed by any objects that could restrict airflow. Regular maintenance and inspections are essential to monitor the condition of the panel and electrical system. These inspections should include visual inspections of the busbars, breakers, and wiring, as well as electrical testing to measure the resistance of the connections. Any problems that are identified during these inspections should be addressed promptly to prevent further damage or failure. Aluminum busbars have been used in electrical panels for many years, often due to their lower cost and lighter weight compared to copper. However, the inherent properties of aluminum make it more susceptible to oxidation, leading to the issues described. When aluminum oxidizes, it forms a layer of aluminum oxide, which is a poor conductor of electricity. This layer increases resistance, generates heat, and can lead to the failure of electrical connections. Copper, on the other hand, is much more resistant to oxidation and provides a more stable and reliable electrical connection. The decision to replace an aluminum busbar panel with a copper busbar panel is a significant one, involving considerations beyond just the immediate problem of overheating breakers. Firstly, cost is a major factor. Copper busbar panels are typically more expensive than aluminum ones. The increased cost reflects the higher price of copper and the more complex manufacturing processes involved. Secondly, the installation process can be more involved. Replacing an entire electrical panel requires a qualified electrician and may involve significant downtime. The existing wiring must be carefully disconnected from the old panel and reconnected to the new one, ensuring that all connections are properly torqued and secured. Thirdly, the load requirements of the electrical system must be carefully considered. The new panel must be sized appropriately to handle the existing load and any future expansion. This involves calculating the total amperage draw of all the circuits connected to the panel and selecting a panel with a sufficient ampacity rating. The National Electrical Code (NEC) provides detailed guidelines for calculating electrical loads and selecting appropriate panel sizes. Fourthly, the environmental conditions in which the panel is installed can also play a role. In damp or corrosive environments, aluminum busbars can be particularly susceptible to oxidation. Copper busbars are generally more resistant to corrosion, making them a better choice for these types of environments. Fifthly, the long-term reliability and maintenance costs of the panel should be considered. While copper busbar panels may have a higher initial cost, they typically require less maintenance and have a longer lifespan than aluminum busbar panels. This can result in lower overall cost over the long term. When inspecting the electrical system for other potential hazards, there are several key areas to focus on. Firstly, wiring insulation should be checked for signs of damage or deterioration. Cracked, brittle, or discolored insulation can indicate overheating, excessive moisture, or chemical exposure. Damaged insulation can create a short-circuit hazard, which can lead to fires or electrical shocks. Secondly, all electrical connections should be inspected for tightness and corrosion. Loose connections can create resistance, generate heat, and lead to the failure of the connection. Corroded connections can also increase resistance and reduce the flow of current. Thirdly, breakers should be checked for proper operation. Breakers that are tripping frequently or that fail to trip when overloaded can indicate a problem with the circuit or the breaker itself. Breakers should be tested periodically to ensure that they are functioning properly. Fourthly, the grounding system should be inspected to ensure that it is properly installed and functioning correctly. A properly grounded system provides a path for fault current to flow back to the source, which helps to prevent electrical shocks and fires. The grounding system should be tested periodically to ensure that it is providing adequate protection. Ensuring proper ventilation around the electrical panel is critical for preventing heat buildup. Electrical panels generate heat as a byproduct of their normal operation. If the heat is not dissipated effectively, it can cause the panel to overheat, which can damage the components and lead to failure. Firstly, the panel should be located in a well-ventilated area. This means that there should be adequate airflow around the panel to allow heat to escape. Avoid installing panels in confined spaces or areas with poor ventilation. Secondly, the panel should not be obstructed by any objects that could restrict airflow. Keep the area around the panel clear of boxes, furniture, and other items that could block ventilation. Thirdly, ventilation openings in the panel should be kept clear of dust and debris. Dust and debris can accumulate in the ventilation openings and restrict airflow. Clean the ventilation openings periodically to ensure that they are free of obstructions. Fourthly, if the panel is located in a hot environment, consider installing a fan to improve ventilation. A fan can help to circulate air around the panel and dissipate heat more effectively. Scheduling regular maintenance and inspections is essential for ensuring the long-term reliability and safety of the electrical system. Regular maintenance can help to identify and correct potential problems before they lead to failures. Inspection should be performed by a qualified electrician and should include a thorough examination of all components of the electrical system. Firstly, visual inspections should be performed to check for signs of damage, deterioration, or corrosion. Look for cracked or brittle insulation, loose connections, and corroded components. Secondly, electrical testing should be performed to measure the resistance of connections and the voltage and current levels in the circuits. This testing can help to identify problems that are not visible to the naked eye. Thirdly, breakers should be tested to ensure that they are functioning properly. This can be done using a breaker tester, which simulates an overload condition and verifies that the breaker trips correctly. Fourthly, the grounding system should be tested to ensure that it is providing adequate protection. This can be done using a ground resistance tester, which measures the resistance of the grounding path. The NEC provides detailed guidelines for electrical safety and maintenance. It's important to be familiar with these guidelines and to follow them carefully when working on electrical systems. Working on electrical systems can be dangerous, and it's important to take precautions to protect yourself from electrical shock and other hazards. Always de-energize the circuit before working on it, and use appropriate personal protective equipment such as gloves and safety glasses. The use of aluminum in electrical systems, particularly in busbars and wiring, has been a topic of much discussion and debate over the years. While aluminum offers certain advantages, such as lower cost and lighter weight, it also presents some challenges that must be carefully considered. One of the primary concerns with aluminum is its susceptibility to oxidation. As mentioned earlier, aluminum readily reacts with oxygen to form aluminum oxide, which is a poor conductor of electricity. This oxide layer can increase resistance, generate heat, and lead to the failure of electrical connections. However, it's important to note that not all aluminum connections are created equal. The design and installation of the connection play a significant role in its long-term reliability. Properly designed and installed aluminum connections can provide many years of reliable service. One of the key factors in ensuring the reliability of aluminum connections is the use of appropriate connectors and termination techniques. Aluminum connectors should be specifically designed for use with aluminum conductors. These connectors typically have features such as serrated surfaces or oxide-inhibiting compounds to help break through the oxide layer and establish a good electrical connection. It's also important to follow the manufacturer's instructions carefully when installing aluminum connectors. This includes using the proper torque settings and ensuring that the connector is properly tightened. Over-tightening can damage the conductor or the connector, while under-tightening can result in a loose connection. In addition to using appropriate connectors, it's also important to use proper termination techniques. This includes stripping the insulation from the conductor carefully to avoid nicking or damaging the aluminum. The conductor should also be cleaned to remove any dirt, grease, or oxidation. An oxide-inhibiting compound should be applied to the conductor before it is inserted into the connector. These compounds help to prevent the formation of new oxide layers and maintain a good electrical connection. It's also important to protect aluminum connections from moisture and corrosion. Moisture can accelerate the oxidation process and lead to the failure of the connection. Connections should be protected from the elements and sealed to prevent moisture from entering. Corrosion can also damage aluminum connections. Corrosion can be caused by exposure to certain chemicals or by galvanic action between dissimilar metals. Connections should be protected from corrosive environments and galvanic action. In some cases, it may be necessary to use special coatings or sealants to protect the connection from corrosion. While copper busbars are generally considered to be more reliable than aluminum busbars, they also have their own set of challenges. Copper is more expensive than aluminum, and it is also heavier. This can make copper busbars more difficult to install and support. Copper is also susceptible to corrosion, although it is generally more resistant to corrosion than aluminum. Copper corrosion can be caused by exposure to certain chemicals or by galvanic action between dissimilar metals. Copper connections should be protected from corrosive environments and galvanic action. In some cases, it may be necessary to use special coatings or sealants to protect the connection from corrosion. Ultimately, the decision of whether to use aluminum or copper busbars depends on a variety of factors, including cost, weight, performance requirements, and environmental conditions. It's important to carefully consider all of these factors before making a decision. In situations where aluminum busbars are already installed and are experiencing problems with overheating breakers, replacing the panel with a copper busbar panel is often the best solution. However, it's important to ensure that the new panel is properly installed and maintained to ensure its long-term reliability.